Okay, today I want to present you a nice use case for OKE Serverless. Okay, and the use case is mainly consumer and producer with OCI Queue. Okay, OCI Queue is a messaging service on OCI. You can see on my tenant, okay, I created before an OKE cluster using the official Terraform stack. And I have a managed node pool, okay, but to be honest, all the VM are stopped. And I have a virtual pool, okay. This virtual pool is for OKE Serverless. In this condition, I don't need to have any VM started or to manage nodes for Kubernetes, as Kubernetes will manage node for me automatically, okay? If we have a look to this presentation, you can see that when I need to create a pod, at the end, you can see that a virtual node is just a virtual kubelet, and that will just run the pod on the OCI service container instance. Container instance is a serverless service to deploy automatically a container without nothing, okay? So it's very simple, and to be honest, this is a mechanism, internal mechanism. You don't need to know that because you just want to deploy pods and to see that the pods are running well, right? My queue here, my final queue is in Paris, okay? I have a code in order to create messages in the queue, okay? So let's go here, send message to this queue in Paris with a small interval. You can see so that first I created an API in order to have the number of messages visible in the queue. This API is running in the Kubernetes cluster, serverless, and I can call the API here. And you can see that for the moment, there is 0 message, okay? The API is running. You can see QDevs API is running, okay? And you can see this pod is deployed on the virtual node. Maybe we can add here something like that in order to see the result. Oh, sorry, I have a bastion. There is a timeout. I need to restart the bastion and to call again to get the pod, okay? As you can see, the pod is running with the virtual node, okay? So with OKE Serverless. Now, looking at the deployment of the code that will read all the messages from the queue. Consumer worker. You can see that I'm using KEDA. I'm using KEDA. And you can see I start with KEDA, okay? KEDA will call the URL of the API. And if the value is over 200, then it will create a new pod, okay? If the value, okay, activation target is 0, it means if I have one only message at start, then I will have a pod immediately, okay? To check that, you can see there is no consumer running for the moment, okay, because no message in the queue. Let's go. I'm starting here and create a lot of messages. Okay, it started. Okay, if we look here to this queue, 33, okay, 97, 99, 81, okay, 99. And for the moment, okay, we can see here what happens if we have a look to the pods, okay. Oh, you can see a consumer is going to be created, okay. And theoretically, when this consumer will be created, he will get all the messages and read them very fast, and the queue size will be 0. Regarding the queue here for the moment, you can see that doing the insert, I'm writing messages in the first queue here and the second queue. The second queue is not for this demo, this is for another demo. This first queue here is very interesting because we see that the number of messages are increasing, but we will see that when the pod will be ready, okay, and running, pending. So for the moment, it's near to be ready, okay. And for the moment, running, it's okay. So the consumer is running. Oh my God, all the messages are read now. I'm writing a lot of message, okay, but immediately the consumer read and delete the message and they are not visible, okay. So you can see it's very fast, it's very easy because I don't mind about the node where the pods are going to run, okay. It's very, very, very easy. And you can imagine if I increase the number of message during this spike load, okay, if I go over 200 here, then I will have another pod automatically, okay. So just stop that, and you can see it's very easy to scale indefinitely with this kind of OKE serverless without managing any load. Just a point that I forget to describe, during the run, you can see that I'm using here in the code what we call a service account, okay? And this service account, okay, is the identity of the pod. And I'm using what we call resource workload principle. I don't need in the code to give all the API key because I don't want to give the API key in the code. I'm using the API key locally. But if I deploy this code on a VM, I'm using instance principle. This code on OCI service instance, container instance, I'm using resource principle. And in OKE Serverless, I'm using workload identity principle, okay? So it means I created here a policy in order to give the right to use queue for workload, namespace is default for me, my OKE service account, and my cluster ID. And you can see my pod is going to run. The security of my pod is the service account. The service account, okay, is able to read queue, and OCI will allow this pod to read queue, okay? So if you want to just have a very nice coding regarding security, you don't give your API key, and you just use this kind of security. It's very secure, and it's allow you to deploy this code everywhere without giving your API key, okay? Okay, so what you see is that for this kind of use case, stateless mainly, OKE Serverless is a super nice solution that can scale very, very easily, okay, up and down. And you see a new pod was created, and what you can imagine is that later, now there is 0 message, okay, and you can see we have, we need to wait, okay, a cooldown period of 5 minutes. We are not going to wait 5 minutes for this video, but believe me, in 5 minutes, the pod will be deleted because we start from 0 pod to read the queue, okay? At 0, then the pod will be deleted, okay? Thank you for your attention.